Hi, I'm Björn Peter Hoffmann and welcome to my video presentation and the experiment reports in analog circuit analysis.
Okay, so let's consider experiment 5 and start with the theory. So we got this circuit, and so this is a step response RC circuit, and if we consider the time below 0, and we got this circuit with the voltage 0, and after T0 we got the infinity voltage of 5 volts. So if we compute R equal, which I've done here, we can compute tau, which is then 22.09 seconds. And if we insert these values in this formula, which we use because of the type of the circuit, we get this equation which describes this current circuit. So with this equation we can compute the voltages at different times. This I have done here. So for example, t 10 seconds, we insert 10 seconds and we get the voltage 1.82 volts. And if we do that for all times, we got this table here, where the voltage rises from T0 to T100 seconds to about 5 volts, a little bit less, here 4.95 volts. And at the curve we see that the voltage rises until it reaches almost 5 volts. And then to B, where we have the discharging process of the capacitor. So we have there a source-free RC circuit. T below 0 we have 5 volts, and T bigger than 0 we got this R equal and this tau. And we use, for this circuit we use this type of equation. We insert the values, and if we insert the different times there, we got our table for this application. Here we can see the table, and so we have then this curve. We start by almost 5 volts and then discharge the capacitor until almost 0 volts. So now let's have a look about the experiment. On the top, on the left, we can see the supply with the plus and the minus terminal, and from there we get to the voltage regulator, where the voltage is regulated at 5 volts, and the connection to the two resistors, the 10 kilo ohm resistor with connection to the ground, and the 47 kilo ohm resistor with connection to the capacitor. And there on the capacitor we have the opportunity to measure with the DMM, and yeah, that's the way how it works. And yes, that's the circuit, how it looks like, and the measurements that are made on it are very similar to the measurements in theory. So after seeing the circuit in the experiment, we can have a look at the results based on the circuit. So we see in this column the experimental results recorded by the DMM, and in this column the results from theory. So we can see it's really similar. For example, in theory after 10 seconds about 1.82 volts and an experimental 1.81 volt. So yeah, it's a charging process, so they're rising until 100 seconds, about 5 volts, like in the theory, and as the graph also looks very similar to the one in the theory. And if we now look at the discharging process, it's also very similar. We have the results based on the experiment and the results from theory. Also very similar, they're decreasing until 100 seconds to about 0 volts, and the curve also looks very similar to the one in theory. And yeah, so theory and experiment, it's work. So the results we get in the theory are shown in a good way in the experiment. So let's see how the simulation works on the example of the charging process. So this is the circuit, we can see the switch over there, and at 0 time this switch is closed and the charging process begins, and we can see how it looks like. So this is a curve, and we can see this curve is very similar to the curves of the theory and of the experiment. And so we're at the end of the video. I hope everything was clear and understandable.